Great. Welcome everyone to Fission's February 2021 demo day on February 18th. We've got a number of short things of what the Fission team has been working on, and then we're going to spend some time with Jeremy from the TiddlyWiki project talking about what we're doing together. Jeremy, if you want to give a little wave.
Hi.
Perfect. Thank you. So thank you everyone for coming. Fission is what we call a fast app publishing platform. So the goal is to design this initially for front-end developers, people who are comfortable working in JavaScript frameworks such as React or Vue or Svelte. And what we want to do is give you all of the other tools that you need to actually bring an app live without having to become a full stack developer, or more importantly, not a DevOps and server expert in hosting. So the way that we do this is we have what we call the web native software development kit. Right now, what it does is it adds user accounts, you've got file and data storage, and basically we want to keep adding things to that SDK so that we put all the tools together that you need to run an app that is used by many users. Including at one point, what we really want to do is enable you as software creators to also sell those apps. That's another movement we feel strongly about, that maybe rather than advertising or selling user data, we can normalize that users pay for apps, much like they do on desktop or mobile. Specifically, we also have some interesting features to help with that. So data is stored in user accounts, and it's end-to-end encrypted. So much like on your phone, when you use an app that wants to access your file system, your phone operating system will ask for permission to that app. That's how Fission works as well. You give permission to apps to write into your file system. This all runs in the browser. So our goal is to make all of this very interesting stuff work directly in a browser, including on mobile browsers. So any user should be able to pick it up and just get into it immediately, and add additional features like progressive web apps that even do things like letting you add something that lives on the web as an icon to your smartphone, so you can launch it similarly to a native app. And we're also working on making our apps run offline, so you don't need to be connected to the internet on your smartphone or on your desktop. So basically what we're saying is, let's make publishing apps as easy as publishing a blog post. I worked on some of the very first blog publishing platforms at scale on systems like Drupal 17, 18 years ago. Shortly thereafter, discovered TiddlyWiki, so it's kind of a nice circle that we're coming back around to that again. App cloning is something that's not quite ready yet. We're going to try some of it with the TiddlyWiki project, where basically as a developer you can make an app so that users can clone it and have a copy of it at their own custom domain. So again, this is like making a SaaS platform without having to build a SaaS platform. There's an emerging term called micro SaaS around stuff like this. And so this is just kind of a fun image. On the left, these are roughly all the things that you would need, all the layers that you would need to learn or integrate together in order to put a full stack app together. And we're saying with the Fission toolkit, we can put all of that just in the browser. In many ways, essentially, Fission takes care of the rest of this stack, making it very simple and easy for you to publish apps, let developers focus on end users, build a business around that. And when I say developer, again, we want to bring that down and have features that are user personalizable as well. TiddlyWiki is pretty famous for being able to get right in there and learn the tool and do things that are essentially programming directly within the app. And we want to enable that same sort of thing more broadly for people. any questions about Fission that I can help answer at this point. And feel free to unmute yourself and just ask questions, or use the chat, and maybe James and Courtney, you can help look for chat questions if I'm not seeing them. Elm. Yes, we run a fair bit of Elm around Fission, and it's a JavaScript, all JavaScript language, but it makes it essentially a little easier to write JavaScript, and it all runs great in the browser. So meet the team. So we are roughly, not to scale, but those are the locations where we have folks on the far west coast in Vancouver and Oregon, all the way to, I think, Belgium is the farthest east. And then Bruno, who works with us quite a bit as an illustrator, farthest south in Brazil, with Helder somewhat inland. Helder, I don't know if you've got it even close. Is Benjamin? Sorry, is Berlin farther east than Belgium? I guess it is.
Yes.
I never think of it that way.
Yeah. Think of the Cold War and stuff like that. Yeah.
Yeah.
Eastern.
Sorry that I had to cut out a major part of the world to fit it on this screen for aesthetic reasons. Welcome, Courtney, who just joined us as one of those dots in the middle somewhere of the US. She just started this Monday, so brand new. This is her first demo day, and has already published a number of blog posts this week and sent out the newsletter that might have been the thing that got you in the door here. Courtney, do you want to tell us a little about yourself? Where are you?
I'm in Charlotte, North Carolina. And yeah, I found Fission through LinkedIn, I think, and got to know the team, and it's been awesome. Like Laura said, I'm just getting started, and so far so good. So be on the lookout for maybe some more cool stuff that I might be able to churn out with time. Let's see, I'm a The Office super fan, and I have a really cantankerous old toy poodle who's always asleep, like right down here. So glad to be here.
What's the toy poodle's name?
Foxy.
Foxy. And also Courtney, as part of just, roaming around and figuring out what Fission is all about, published her first Fission app. In fact, using the command line on your Mac, I think on your second day, wasn't it?
Yeah, I was just up tinkering around, and I think I've been in the command line like 2 times before, but I guess it shows that the documentation's good because I could follow it with like no idea what I was doing. So
woohoo! Publishing for anyone who doesn't know what they're doing. We'll work on the Courtney and I will work on the phrasing there a little bit. Awesome. Next up is Helder. And also, I thought I'd just continue the theme of using little flags everywhere. I don't mean to pretend any allegiance to any particular states. It's more like a location indicator. Helder, do you want to share your screen and have me stop mine here?
Yeah. Can I share the one? No. The one that have the computer. I have two connections here. Oh, okay. Yeah. There it is. Can you all see this? Wait. All right. So I'm going to, well, my name is Helder. I'm agent of user on Twitter. I'm going to speed through this a little bit because there's a lot of cool stuff coming up. But I'm going to show the work we've been doing on having Headless Ghost static websites deployed to Fission with automated GitHub action. And the idea is to use Ghost, the CMS, as the familiar editing interface for content producers, and then have that content get used via the API and pulled into a Next.js website that compiles it into a static website using React, and then deploys that to the Fission platform. So Fission has a Heroku starter here that makes it easy to deploy a Ghost CMS to Heroku. And I have one running here. I'm not going to do this live because it takes a while to build everything and to deploy everything the first time around. But you can see here that I'm using like the starter plan for everything, so it's easy to get started, and I can use the Heroku add-ons for MySQL and email, and there's the Fission add-on for Heroku that uploads images to IPFS. So I've deployed a test Ghost instance here that you can see running here. This is the public website on the Ghost CMS, which you can hide to make it private, so you don't have duplicated content and you don't need like to expose it to the world. And in the admin interface here on the Ghost CMS, you can see there's an integrations tab, and you can add an integration here for Next.js, and it exposes a content API with some keys here that you can set up with the Fission action on GitHub. So this is the Headless Ghost with Next.js on Fission Starter that people can use this template and make a copy of it and get it deployed to Fission. Uses the publish action, which is a GitHub action that deploys to Fission. And here I set up the secrets for the action to use for the Ghost. It fetches from the Ghost API and uses the Fission key to deploy the website with that content. So you can see here in this page, it has this continuous deployment running. So whenever you push changes to the Next.js website, changing a React component or visuals, it gets compiled again, pulls the content from Ghost, and deploys automatically to Fission. Here's one of these deployments. You can see it built the Next.js website here, and then it runs the Fission publish action and puts it on IPFS and sets up at this domain that we can visit here. So you can see that this is Next.js website compiled, and it's a static files running on Fission on this oval butterfly subdomain. And you can see like the default posts from the Next.js starter, and also like the ones that were pulled from Ghost. So this is like Ghost content on the Next.js website. It has the welcome to Ghost here, and it's statically generated with Next.js. So the flow would usually be like you come to the admin interface here on Heroku, on the Ghost CMS, you type up a new blog post, hit publish, and you can see here on the Ghost side, which can be made private, and then the GitHub action pulls it from Ghost. You can trigger a new build by running the workflow manually, or when you push new changes to the Next.js code, and then it gets built into the website and published to Fission. So here's a new post, and it runs here. And if you look into the little picture here, it's also on IPFS. So this data didn't have to be moved around from Ghost to Next.js. It's all on the IPFS platform. So that's the basic gist of it. If anyone has any questions, you can join our Discord, and I'll be happy to answer them. Yeah, thanks.
Jazz hands are a tradition here, as instead of applause. Helder, that was fantastic. I really like the way that you did a browser tab-based presentation. That was very slick. Thank you.
Yeah, thanks.
So this really showcases that, so headless is a general thing where systems that have been around for a while, like WordPress and Drupal and Ghost, people are now realizing that it would be nice to be able to do a lot of these things on the static web, which you can cache and run offline and is highly secure because there's no database running. And so this is an example of that. Helder put a whole tutorial together. So the Fission platform can be used for quite heavy GitHub and deep developer focused workflows. So our goal would be, just like we can do a one-click deploy of some of the Ghost stuff, is to make these front ends more available so that can just be dropped in for WordPress developers, where ideally we can go in and you can literally just on the web edit a config file to point to where your WordPress site is, as an example. And then you would immediately have this novel front end with Fission powered features. What Helder has also done and documented in the repo is the other version of this is that you can just run the server on your desktop. And you don't need to leave it running. So you can have a really rich editor for a CMS, whether that's WordPress or Ghost, and do all your editing in there, hit publish, and then turn it off when you're not using it, which is a pretty cool feature. So we can lean on the 10, 15 years of editing interfaces without having to retrain people on that, and then have a super modern static website that typically would have needed nothing but developer tooling and no editing by end users whatsoever. So this is kind of the best of both worlds. I didn't realize, so you're mixing and matching Markdown posts and Ghost CMS posts?
Yeah, I use the standard template from Next.js, which allows Markdown posts, and added the ability to fetch content from Ghost. So you can do both. You can have developers or people who want to edit Markdown do that, maybe on the GitHub web interface. And you can also have other types of posts coming in from Ghost. You can pull data from pretty much any place.
That's great. I could see the utility for highly designed marketing and landing page sites that might get done, again, more of a developer designer workflow, whereas kind of standard blog posts are perfect to be coming in from Ghost. Yeah. Awesome. Yeah, Aaron mentions that he uses Statamic and Laravel. This pattern should work across all CMSs, really. Some don't necessarily have hooks for them yet, but we're happy to help figure that out as we do more of them. Okay. Anything else, folks? I'm going to move things around fairly quickly. We have it all on video, and then, as Helder said, please do come join us in Discord or in the forum to come and talk some more. This is our so Helder, I'm going to ask you to stop sharing again and switch over to mine. Thank you so much. We have a tendency to make custom icons for things. So this little, this is our first Headless Ghost mascot. And they have the little ghost logo in their badge here. And we'll be having some more, as I think WordPress is probably going to be up next as we work on that. So headless space people are coming to a sticker pack near you. All right, next up is the Filecoin Backup App. So Benjamin and Brian, if you can give us some waves initially, great, fantastic. So Filecoin is a blockchain specifically for storing files in such a way that we can kind of keep files online without having to rely on particular organizations or companies. And these things are quite tricky to connect to browsers. And because all of Fission stuff is meant to work directly in browsers very securely, we propose to work with the Filecoin team on a grant to basically make it so that you can use these private security keys directly in the browser without having to share them with any third parties. That's another kind of thing that we do. Instead of having to trust a developer, you're just trusting your user accounts and how they work. So Ben is the research lead on this, based in Berlin, and figured out a fancy way to do this with cryptography. And Brian is leading the development of the front end app. If you've seen Fission apps before, they generate fun names. So Ancient Round Crab is the in progress app. And I asked Brian to say, well, clearly we need a crab. That's not a full mascot yet. We'll get there. And you can follow the forum as we work on that in general. We're working on that out in the open as we tend to do. I will hand it over to Brian and Ben now.
Hey, I didn't know that we had a mascot, and I didn't know that I love the crab, so great. You learned some everything. I made some like super ugly slides, but I'll just keep this at like, hold on, where did it go? This is not my slides. Here's my slides, sorry. I'll just keep it like 2 minutes, 5 minutes max. But just to give a little bit of an overview, are you seeing the video? That's not on the share screen, right? But okay, I also see everyone's picture. Just as like a placement context. So in purple, you have like the existing Fission stack, right? So what we do with Fission, everything is in the browser, and you have the web native SDK, which encrypts all your data, well, excepting the public one, and asks Fission to store it on IPFS and report to DNS like the latest state of your head. So this purple architecture we already have, and what this project is about is extending the Fission ecosystem into the ability to, if you'd want as an app, to also do like cold storage snapshots of your data to Filecoin. And so the green parts are what we explicitly building in this project, and Filecoin is here together with IPFS in blue. The tricky part is we need to be able to talk web to blockchain, and that's sort of the research part of this project, but we won't go too much in detail here. Mostly we want to sort of give an update on where we are. Why we call it a cosigner, maybe as a short word, is the architectural choice we've made is that we store, you can do with what is called Bls cryptography. It's elliptic curve cryptography. It's a special kind, and it allows you to, in particular, combine two keys into a new key, which function as if they were one key. So you can sum two keys and make them one. This allows us to have the user one part of the key and have a cosigner service on the Fission stack be the second key, so that we can secure the browser where it signs. The reason we can secure it is because we have Fission, right? So Fission has a permissioning system with RSA keys that are non-exportable from your device. And so we use that to ask this second BLS key to sign any transactions. Otherwise, like the security wouldn't complete. Anyway, I won't go into much detail. Again, if there's questions, like we can go into that. We've been at this for a short while already, and so the first phase of research is completed, and now we're implementing. And so Brian is doing great work on the front end app, and he'll talk and demonstrate a little bit later. We started with like a rough user sign up flow and fill, but it's all fake because it's not connected to chain yet. There's the SDK part, which also runs in the browser, which any app would interface to talk to Filecoin, and then there's sort of this service that runs to cosign. Where we are at right now is just like say 30 to 50% of like early prototype code, understanding Filecoin and understanding the UCAN flows. This diagram I just made in an effort to make it a little bit simpler.
Did you just say the word simpler?
Yeah, but the most important part here is like it's ugly first. I mean, that's maybe not the most important part. It's definitely not pretty. But the emphasis is just if you're familiar with a user with a flow diagram, you might see that you normally like the requests originate from the user, and then the actions actually take place on the service side. And if you take nothing away from this diagram, but this one thing, then it's that everything really happens browser side. So the only thing we request Fission to do is to store encrypted data. The only thing we ask cosigner to do is add as additional signature on things, but everything really is orchestrated from the browser.
So just go back to there for a second. So this is some pretty deep stuff. We want to showcase it because we get it on video and share it with lots of other people. The other takeaway here is, so this is a pattern with a blockchain that uses some pretty intense private keys where everything is being initiated user side. So imagine the same thing where your Fission apps have the keys to your Twitter account or other server-based systems. So while we're fully client-side, what we want to do there is in general, make it so that developers have all the tools they need without having to go to servers. And TiddlyWiki has experimented with a ton of these techniques over the years. And that's kind of the pattern that we're trying to work on as well. So without having to run your own server infrastructure, can we still keep it secure? So that the general pattern is similar to how Apple keeps everything encrypted in an iCloud account for you, and you do stuff from your user account. And that's the kind of thing that we're trying to make available open source and in your browser. With Fission does various things on the server so that you as a developer don't have to, but all this stuff should also work offline and even be something that the user can host themselves to keep their own copies of the data and so on. So same pattern. This is really great, Ben. Just to be clear, this is the first time I'm seeing these diagrams as well, so I'm reacting live to this stuff.
I also made them only an hour ago.
Yeah, perfect. If you've only got a minute, it only takes a minute, right? Perfect.
Maybe another thing that I wanted to showcase with this is also that you can do everything in the browser without installing plugins, right? And so people we're very excited about like the WinDB work, where you can have collaborative apps, and that's a great project. And with this project, from your private applications, you start being able to connect to blockchain systems, Filecoin in particular here, but it's rather generic, without needing to install extra plugins and whatnot, and it all just works in the browser, controlled by the user. Sort of the main takeaway. We can then, Brian, if you want to first talk a bit about the front end app, or if we want to like open it, I can also do that.
Yeah. Let me talk about it a little bit here, and then we can open it. As Boris mentioned, the app is written in Svelte and uses the Sapper framework. The Sapper framework is kind of this client-server framework that's built for Svelte, that does static sites or sort of node-based sites, and eventually will become SvelteKit. It also uses Carbon Components Svelte, which is an implementation of IBM's design system. The Svelte ecosystem has like Material and Bootstrap and a bunch of other sort of design systems, and we thought we'd give IBM's a try, and it's pretty nice looking. And the app itself will show balances for the wallet that's held, the sort of BLS key, the wallet that's held in the app, and then balances that are held by a Lotus node. A Lotus node is kind of like a custodian that holds like your, it's like an intermediary that holds your Filecoin wallet, and that's what's used to do the actual transactions. So this page in the app shows transactions from the wallet to the Lotus node. And in this app, Web Native kind of acts as hot storage, because the idea with Filecoin is that it's cold storage. If any of you are familiar with AWS Glacier, it's kind of that idea where you're going to make a storage deal, and you expect that it could take, 24, 36 hours to like get your data like stored, but then it's guaranteed to be like really durable storage. Maybe also a little bit slow to recover. And so web native, since we have sort of storage and it's fast and it's easily accessible, acts as kind of like a hot storage place where you have quicker access to your files, and you can upload them and save them to Filecoin. And then storage deals is that's what they call it.
Yeah,
go ahead.
No, sorry, go. So maybe we're on a delay here. You go first, Brian. Sorry.
Okay, sure. Yeah. So the storage deals, which is the deal that you make on the Filecoin chain, are to store things to Filecoin, are paid from the Lotus node. And yeah, go ahead, Ben. Maybe you want to say a little bit about why we have this Lotus intermediary.
Yeah, so on this, like we can also go to the page, I guess, maybe. I don't know if this will work as a live demo, but you saw two balances. The reason for that, so here in the top corner as well, like there's my own money wallet with which I can buy prepaid credits. The reason we need to split this up is just because a storage deal might go corrupted, and we want to have Fission ready to repair it and have the money to pay for that repair if it goes down, because the browser app obviously is not always open. So that's why we need to split these two things. But I wanted to just emphasize that the money is held non-custodially. You just prepay Fission to make sure that they have money to repair any deals if a storage deal gets corrupted. That was just my small remark. But yeah, the app, I'm already logged in here, but this is the page we saw.
Yeah, so the top right, you've got Ben's Fission account showing Ben Ballin in there. So Brian's implemented web native login already, and if you're not logged in, you can prompt to log in. It is live, so I've just put it in the chat. So it doesn't do anything right now. This is us working on the UI and the flows. But we tend to work out in the open. The GitHub repo is open as well. And we're working with the wider Filecoin community on some of these bits and pieces. And it lets us test a lot of different things. So we try and say, okay, let's use Svelte for this one. And let's make sure that we have an example of how to integrate Svelte with Fission's work. And that's kind of the pattern that we do. We'll always have different experiments of different things that people want to see, and it'll give us an excuse to talk to a different community.
Right. That's, if there's any questions, I'll stop the share.
All good.
Find us on Discord. Happy to talk.
Fantastic. Thanks, guys. Jazz hands. Okay, one more intense technical thing. The pentagram from Daniel. Yeah, I'll go ahead and share. I don't need to switch to my screen and then just to yours. So
okay.
So as we've kind of hinted at to set this up, we use something called the Interplanetary File System, which is a global peer-to-peer network. So in many ways, we think of Fission not as a cloud provider, but as a constellation provider. We keep files online, and we built encryption on top of this IPFS stack. And Fission runs IPFS servers so that we can make sure that your stuff stays online. It technically is actually served directly from your browser as well. So Daniel's going to go through some recent backend infrastructure work that he's been the lead on to improve performance of our systems. And specifically, I think we've got some stuff now deployed in Europe, Daniel?
Yep, in Ruston, Virginia, and Stockholm, Sweden.
Yeah, so, and we can follow the same pattern as we look at other areas of the world. Obviously, Helder, way down in Brazil, probably needs some servers close to him as well. Go ahead. Thank you, Daniel.
Sweet. Can you guys see the slides all right? Okay. Yeah, so this is going over IPFS Cluster. We used to be hosting just a single IPFS node, and now we're running 5 of them. So to give you an idea of what our setup originally looked like, we were hosting an IPFS node. Its data store was backed up in S3, which is just like blob storage on Amazon. And so people would connect to that node, they would send data to it, and the node would send data back to them. So the downside of this is that it's a single point of failure. If that node goes down for some reason, people aren't able to get their data out of IPFS, or at least from that node. It might be replicated somewhere else, but aren't able to get their data from that node. More common than that node just straight up going offline, which we never really saw. Maybe it might have happened like once. Is that it would just get overwhelmed with traffic and bombarded from a bunch of different users, and then it would really slow down transfers to somebody that needed something. And so what we wanted to do is have other options available for users that wanted to get their data off of the network. So that brings us to IPFS Cluster. Right now we're running 5 IPFS nodes. 3 of them are in Ruston, Virginia, US East 1 for AWS people. And 2 of them are in Stockholm, Sweden, EU North 1 for AWS people. Both of those are still backed by S3. And the interesting thing here is that all of the nodes within a region share an S3 store, which makes them a lot faster because they're all accessing the same data. And it also saves a lot of data duplication. We're not storing files 5 times, we're only storing them twice. So you still get data duplication, but it's not, you know, let's say that we bring up 20 nodes across the world. We don't need 20 copies of the same file. Just to briefly give an idea of what this looks like in the back end, each node is a separate server running with an IPFS daemon on it. And they also have an IPFS cluster daemon on it, which is a separate process running. That cluster process is really in charge of 2 things. It's in charge of keeping all of these nodes connected, and it's also in charge of keeping track of a global pin set shared by the cluster. So whenever you ask one of the cluster nodes to pin some sort of content, it then sends a message around to all of the other nodes in the cluster saying, okay, we need to start tracking this content now. And all 5 nodes will replicate that content, and then they're able to serve that to users as well.
The pentagram.
This is the pentagram. Ignore the vaguely satanic undertones of it. It's just a consequence of having 5 nodes running. So the cluster is completely interconnected. That means that if one node has access to the content, all of the others should have access to it as well. And it means that if your content is stored somewhere on the cluster, you can connect to any node in the cluster and start pulling that content down. It also means that you can connect to more than one node in the cluster and pull that content down even faster. We didn't do super rigorous testing on the speed improvements from this, but just from giving it a go, it seems like uploads and downloads are anywhere from 2 to 3 times as fast, mostly owing to connecting to multiple nodes.
Yeah, so just to pause there. So basically, the way that Fission works, especially if you include web native, is that we're actually running an IPFS node in JavaScript in your browser. And that connects to these servers in this network as well. And we technically don't do uploads. As a developer on your file system, you're adding stuff to the IPFS network and then asking our servers to fetch it from your machine. So really, we're connecting this stuff in a much, much more peer-to-peer way. And for those of you who might be familiar with BitTorrent, because it's been around for a while, IPFS functions a little bit like BitTorrent, where multiple servers can have the many pieces of the file. So whether that's your browser or your desktop or our servers, multiple servers can participate in sending little bits of files around. Is that about right in explaining it like that, Daniel?
Yeah, that's exactly right. So this is all peer-to-peer, and so you have these connections to multiple IPFS nodes. So you might get 40% of the file from one, 60% of the file from another another node, and then locally on your client side, you put that together into the file. And as Boris said, you're actually running a node in your browser with full peer-to-peer capabilities. So someone running a node in another browser can even connect to you and get some of the files from you. So the more people that are online, the more these files are being served and the higher availability they have and the faster the transfers are. And in contrast to the single node that we're running, let's say that a couple of these cluster nodes get overwhelmed or go offline, and it kills the connections to those. Users can now just start new connections to other cluster nodes and expect to see similar upload and download speeds from them. So it creates a much more resilient network, and you can expect less delays if the network is seeing larger volume than normal. So the tooling that we used to build this was a combination of Terraform and Nix. This was pretty fun for me because I didn't have too much experience with either of them coming into it. So to give you an idea of it, Terraform is a way of describing your infrastructure in code. And so the Terraform component of this is in charge of setting up all of the infrastructure in AWS. So spinning up those EC2 instances, creating Acme certs, creating DNS in front of the instances, things of that nature. And then once the infrastructure is actually upline on AWS, then we switch over to NixOS, which is a way of programmatically setting up some machine. And we set up all of the stuff that I just talked about. So it creates the IPFS daemon, it creates the IPFS cluster, it runs an Nginx proxy for routing requests between ports. It's just really nice because we get this entire picture of the setup using these two tools. And let's say that we want to put a new cluster online, we run one single command and it does everything for us, puts up 5 new nodes or more than 5 new nodes. All we have to do is change one variable and we can have nodes in Brazil, for instance.
Awesome.
So yeah.
Thanks, Daniel.
Yeah, Gary?
Just one quick comment. When I actually had the same thing running on my Android and the browser, so 2 more machines, then it's actually fast as well. So that can help. So the more devices you use your stuff, the faster it is. But it is much faster now. Thank you very much.
Awesome.
Yes, that's great to hear.
Yeah, and in general, what I said before about us being a constellation provider, we're working on things to make it easier for people to run this locally on their own machines. This will be early adopter stuff. Jury, as an example, loves running a bunch of these things because you're running apps, but the data is all being served locally. So the code for this is all open source as well. So if other people want to spin up more of this network out there, that's all available. That's something that we hired someone to help us with get going, and Daniel continues to maintain. And that's what we use. And that's our general pattern is we tend to, if something's not available, we'll try and extend something that already exists. Or if we do create it, make it as open source so other people can use it. Okay, TiddlyWiki on Fission. Fantastic. I'm going to turn off this slide because we don't need to look at it. We've got a blog post up about this. We've got some tweets about it on the Fission account. And there's a dedicated category in the forum to continue discussion around this. I said hello on the TiddlyWiki mailing list, so I'll be monitoring that as well. So I will bring Jeremy up on stage, as it were. And we had Jeremy actually, I guess I wrote a blog post last May about TiddlyWiki. It's something I've been using for a long time, and it's sort of serverless in the same way that Fission is sort of serverless. And then we had Jeremy on for a Thursday chat in October. And then finally, I guess it's been 2 weeks now. Jeremy's been wrapping his head around web native and Fission and working on bringing TiddlyWiki to Fission. So Jeremy, do you want to maybe just introduce yourself and TiddlyWiki your thoughts so far? Muted. Got it.
Thank you, Boris. Thank you, everybody else as well. Yes, so let me show you. TiddlyWiki, as Boris says, is a serverless application in the painfully literal sense that actually possibly isn't that helpful, that it doesn't use a server at all. And that also makes it server agnostic in that it makes it much easier to plug into an arbitrary server that you have lying around, because it doesn't have any dependency on the server. So normally, if people want to use TiddlyWiki, they would come to tiddlywiki.com, maybe download it themselves first, but you can just do it like this, where instead of typing, I'll draw something. And now to save changes, I click this button, and then the browser downloads a new copy of the HTML file that incorporates my latest change. So that's obviously a nightmare.
Did you want to share your screen?
Oh, I'm so sorry. I do that every time, obviously, as well as being on mute every time. Forgive me. Let me re-prepare that demo. Forgive me. Okay. So this is TiddlyWiki, and I was what you couldn't see me doing was I created a new item, and I chose to create an image item. Click done. And now to save changes, because this is a single HTML file, I click the save button, and the browser downloads a fresh version of the file that incorporates my change. And so the next time I make a change, I do the same thing, press save, and here's my latest change. So that's a very tedious process, but it demonstrates the remarkable quality of TiddlyWiki, that the entire application, including in this case a graphics editor, is all built into a single HTML file. And it's the thing that made it very easy so far to integrate with Fission. And I should caution that this is very early days. We're at the point where programmers have a kind of happiness curve when they're working on projects where it's all a bit baffling, and then you suddenly get things to work and you think, oh, it's nearly done, and then there's all the little niggly stuff, and I'm at that very early stage of excitement where we've got it working end to end, but in all kinds of ways, both internally and externally, it's a bit of a mess, but still. So this, you've got to imagine it is running at tiddlywiki.fission.app. I think that's right, isn't it, Boris? And I've already authorized with it, and so that's why it knows my username. We should be able to, at this point, choose which of my wikis I want to edit. So TiddlyWiki has a desktop application called Tiddly Desktop that has the same kind of user interface we're thinking of, where you register a wiki, and then you can click to open it, work on the wiki, and make changes. But at the moment, all we've got is a brutal button. And if I look at the source code of the button, you can see the path of the document that I'm editing is actually hard-coded. So that's it's very early days. But if I click the button and open the link, it now opens a TiddlyWiki document that's stored on my Fission drive. And I can show you that if I, so this is the web-based interface to my Fission drive. I can choose link to file and get a public link to that version of that file, which is the version of that we've just been looking at. So,
and what we're doing there as well, if you can, you actually bring that page back up again, that same link. So if we look at that one? Yeah, no, the TiddlyWiki on Fission, the IPFS gateway link there. Next one, farthest right. Oh, farthest right.
Oh, right, that one. Yes, sorry.
So we just went over talking about how this is a peer-to-peer system. So this is an example of this particular version of this TiddlyWiki is available public on this global network, right? This is a public file and it can be served up anywhere. So it can be locally on Jeremy's machine, but it also is available everywhere with that unique path. So that's one of the really interesting things. A server going down in the IPFS network means that this still stays up, and as long as one person at least is connected to the network, it will always remain available, which is a pretty cool feature.
Indeed so, indeed so. And I may say, Boris got through the initial introduction to Fission without mentioning IPFS, but I kind of came at it from the other side. I've been interested in IPFS for years, but have struggled to get other people to adopt it, I think it'd be fair to say, because of the requirement to use a custom browser and so on. And Fission is really giving us all of the things that were exciting about IPFS, because it's still IPFS, but making them much more accessible. But I'm already showing something deeply confusing here. This is a path into Fission's IPFS storage to my public file. And if I try and make a change here, just to emphasize, it's a, where is it? If I try and make a change here, like adding a new tiddler, when I save changes, it'll fail to save the changes. So now if I refresh, I don't see those changes. That's because it's a static read-only view. It's just TiddlyWiki is confusing you by presenting its editing user interface, even though it's non-functional. But this view, where I'm looking at the same file through the app, has the editing capability. So I can say hello to people, and I can draw a smiling face on that. Okay, that's my like a pumpkin. And now you can see it's been merrily telling us that it's saving in the background, and we can, in DevTools, we'd see lots of network traffic as, so it's not really uploading, it's doing this complicated syncing process. So I'll now close this tab and reopen it, and you can see that it includes my face.
Boom.
So that's the normal, nobody really uses that user experience where you save a file each time you save changes in TiddlyWiki. It's a kind of fallback position. So this is the normal way to use TiddlyWiki, where it just behaves like any other web application. But of course, here I've got the capability to show a public version. I was just going to, for the Cody people, just going to very quickly show the almost embarrassingly simple guts of the thing, which is code to read the file from web native. So we call fs read and stick it in an iframe. And the code to save, similarly, we do an fs write, and then the only unexpected thing is this publish call that's necessary when you've finished a whole bunch of changes to dispatch them into the ether. So really, the API was remarkably easy to get my head around. This is, for me, quite an interesting, a lot of the work I do ends up being a kind of symphony of iframes, and that's rather the situation here. If we look at the editor, you can see right up at the top, there's an iframe there that contains the TiddlyWiki document. And right down here, there's an iframe that does magic stuff to Fission. So that's really why the HTML page is so trivial. It's hosting one iframe containing the TiddlyWiki, and it's just scurrying the traffic backwards and forwards to this other iframe containing Fission. And the beauty of JavaScript and browsers now is that these APIs are really smooth. You wouldn't know that you weren't talking to a normal JavaScript API.
Awesome.
I think that's my demo done, but I'm very happy to answer questions. Thank you.
Yeah, so basically what will the plan going forward is, as Jeremy said, we will be, we're still working on the source code and it's not public yet, but as we get it cleaned up and working, we will publish the GitHub source. We welcome anyone who's working in TiddlyWiki land. You don't need to be a super dev expert. If you have an interesting addition or kind of customized TiddlyWiki that you'd like to share, we'd love to basically have a number of different example templates that people can choose from in the TiddlyWiki on Fission app. And you know, Jeremy and I have talked more about basically working very closely with the community on this to expand capabilities and do more with it. We'll invite people to kind of try it out, ask for features, and we can see which of them we can get in, and then really develop it as a community over time. So what Fission's goal here is that we want to showcase the kinds of things that you can do with sort of user-owned apps. I had one question on Twitter where someone said, oh, I keep my like second brain TiddlyWiki, I keep it private. Will that work on Fission? Yes, absolutely. In fact, the private version, you've got a fully encrypted file system. So you're not writing into a public index.html. It's all actually inside your own file system that you're carrying around with you. So that use case is actually an easier use case in many ways than the public one. And I'd love to get to a point, and we'll talk about this in the forum. We welcome feature requests. I'd love to get it where I can run a private TiddlyWiki where I can selectively publish tiddlers or portions of something like that. And that's exactly what Fission is well built for. And as well, for those of you who are consultants or working on using TiddlyWiki powered things, we'd love to basically help use the Fission platform so that you can make 100 or 1,000 instances of a customized TiddlyWiki to a particular audience without having to build all this server infrastructure that we just gave you the view on. Any questions on that we can help answer? Fission, TiddlyWiki, IPFS, anything? All right. I have a few more things. We've just hit an hour, so I like to keep you not too much longer. So stay tuned in the forum if you want to get involved, and when we publish the GitHub repo as well. If you're more of a developer bent, we welcome people to work on that as well. So the next thing that we're working on, a little bit of an update, mentioned it that Courtney helped get this out the door. Account recovery is something that we're moving forward on. So we're doing all this fancy stuff with linking things into your browser without a password. Much like Apple using your different devices to unlock your computers, that's a similar pattern as how Fission accounts work. But we do need to have sort of a backup and recovery thing without giving Fission the keys to be able to look at your data. So we are looking at this for, in fact, a use case where an app expects a lot of users to have only a single smartphone. That is the main case that we have to support a sort of backup of your private keys. So you can look at that blog post for some of our thoughts on that, as well as links in the forum where we've got some early design flows of what that's going to look like. Events. I was thinking, Jeremy, we don't actually have anything planned next Thursday. So maybe, and we can keep talking about it between now and then, maybe we'll actually even, I'll just host a sort of community drop-in next Thursday, and we see if people want to drop by and talk about that. We tend to have things Thursdays, but we don't religiously have something every Thursday. A couple of items are coming up in March already. Dylan Steck is building a cool tools for thought, tools for action app. He was the first one to integrate Fission into a Chrome browser extension. So writing a browser extension as well, he didn't want to have to run a bunch of server infrastructure. So he did a first try at integrating Fission. So that was really great to see. And he's going to come and demo what he's building with Cortex. A young man in New York who I had a call with, and really looking forward to hearing from him. March 11th, James Long builds a really interesting local first personal finance app. So something where the data is kind of very personal and critical. And he ended up migrating from a desktop app to a web-based one, but used some really, really interesting techniques that are similar to some of the things that Fission does to put all this stuff in the browser. So he's going to come talk about that. Last week, we had Project Cambria, and the video is up for that. We're looking at using that because what it allows you to do is to have, for your app and the way your app stores data, it's complicated. As you update your app and you change the data format, how do you make sure that different versions of an app can still have compatible data? Which is always a terrifying thing when you have to go as a user for updates between apps. And they're working on some really interesting stuff like that. For us at Fission, there'll be two pieces to that. One is app compatibility with different versions, but the other one is because all of your data is stored in your file system, we think this might actually be very interesting for data compatibility across different apps. So that was a great, very technical presentation and has given us lots of ideas. And I know Stephen is already tinkering around with it with some Fission stuff. If you want to hear a little bit more from Fission, in fact, I'm wearing this same shirt, I just realized. We put up a blog post about a 15-minute interview with me. I've been kind of building stuff for users for 17, 18 years in the first try at putting blog posts online. And I'm excited to be working on this with Fission on apps. So you can hear a little bit more about how we think about that and where we're heading. Does anyone else have announcements of projects of their own or any news to share? Literally open floor if you want to share anything. I'm just adding this in, so I'm probably going to need to prompt some more people ahead of time to be prepared to speak up on video. Awesome. Any other questions that we can help answer for people right now? Come on, Aaron. You're gonna do the first atomic headless on Fission. Fantastic. Amazing. Well, thank you very much, everyone. I'm going to finish the video now. So we're off on video. Nope.